Welcome to the Impact Technical Products channel. I'm Amelia. We are manufacturers representatives covering the Canadian market, specializing in the technical aspects of the datacom and networking industry, with a focus on high performance spaces like data centers, as well as mission critical harsh environments. We had the pleasure of doing some troubleshooting of a data center last week that had a few hotspots, and I was able to take a video that I think could be educational, so please enjoy. So we are standing in a data center that has having some heating issues. So I have a clear E96 camera, and I'm going to show you where the heat issue is coming from. So if we look here, we can see that the top of the cabinet is disproportionately hot compared to the rest of the room. Now, what's important about this specific camera is that I have a wide enough angle lens that I can see everything I want in my field of view. It also is high enough resolution that I can see the detail and measure the temperature that I want to measure. So let's investigate why the top of this cabinet is so warm. And what we find here is we have air dams on the side of the cabinet, but we have no air dams on the top of the cabinet, allowing hot air to recirculate from the back to the front. So let's unpack what we saw. Why do I care if a data center has a hotspot? And what caused that hotspot in the first place? Let's answer the second question first. Equipment that consumes energy heats up over time. In an IT setting, when I say IT, I mean a clean environment like a data center. There are fans inside of the equipment that are used to dissipate the heat. Generally, those fans are positioned such that the air is sucked in from the front and exhausted out of the back of the equipment. When air passes through the equipment, it heats up. Because we have fans that are actively drawing in air from the front of your equipment in your cabinet, it creates a negative pressure space at the front of your cabinet and a high pressure space at the rear where the air is exhausted. That means that air is likely to be pulled from the back of your cabinet to the front of your cabinet. As we discussed, the air at the back of your cabinet is hot, and so that can create hot spots if air from the back is recirculating to the front of your cabinet. So back to the first question. Why do I care if my cabinet has a hotspot? Well, the hotter the intake air of your equipment, the less that air is able to cool your equipment down, meaning that your overall equipment temperature is going to rise. Again, why do I care about that? Well, equipment for clean environments is only designed to operate up to a certain temperature, and exceeding that temperature can lead to premature equipment failure. Luckily for us, ASHRAE has thermal guidelines that save us from trying to calculate the maximum intake temperature that's acceptable for every piece of equipment. There are different classes that your equipment could be designed to, but the threshold maximum temperature of 27 degrees Celsius works for all classes of equipment, and that is ASHRAE's general recommendation. I suppose that brings up a third question. How do you prevent the intake air from exceeding 27 degrees Celsius? Well, typically that's done with a combination of air conditioning and airflow isolation. Airflow isolation is the practice of isolating hot air from cool air. This can be done with hot aisle containment, cold aisle containment, or chimney cabinets. There's really only 3 ways, and none is more correct than another. Largely, your room dictates which solution is best for you. In our example, we were using chimney cabinets. So let's take a look at the thermal image that I captured while I was there. In this image, we can visually see that the hottest area is located at the top of the cabinet. I placed a spot there in FLIR Thermal Studio so that I could measure the actual temperature, and it was 32 degrees Celsius, which exceeds the ASHRAE standards of 27. Thermal Studio allows me to create a report that I can use to document progress. There's a lot to know about Thermal Studio and infrared inspection and cameras, so we'll cover that in a future video. But for now, infrared cameras helped us identify that the top of the cabinet was hotter than acceptable. We saw when we performed a visual inspection that there was a gap between the top rack unit and the top of the cabinet. So that gap is usually closed with something called an air dam. Air dams are a small piece of rubber that are used to close small gaps in the cabinet, a material similar to a windshield wiper. We'll be sure to update you with new thermal images once the air dams in the cabinet have been replaced.